Right, question 8 is the electrolysis question, and we've got the setup here that hopefully you recognised as a setup to purify copper, an impure copper electrode on the left and a pure copper electrode on the right. And the question's asking for the energy conversions. We have a battery at the top, which gives us the electrical energy, and that then drives the chemical reaction that takes place. So the conversion is a conversion from electrical energy to chemical energy. A2, which electrodes the anode. Let's just look at this slowly. If we have a look at the battery, the long end of the battery indicates the positive pole, the short end the negative pole, which means that the left-hand electrode, the impure copper electrode, is positively charged and the pure copper electrode is negatively charged. And a little memory aid, Euler rig, tells us that oxidation is loss at the anode and reduction is gain. So we're looking for the electrode at which electrons are being lost. At the impure copper electrode, copper atoms are forming copper ions and releasing 2 electrons, and they're your 2 electrons that are lost. So that's the electrode that oxidation takes place at, and therefore that's the anode. So it's the impure copper electrode that loses those 2 electrons, and so the impure copper is the correct answer there. The name of a suitable electrolyte for this reaction, all you need is a soluble copper salt. So any soluble copper salt will do. Copper sulfate is probably the most common one. Copper chloride would do fine, and copper nitrate also. 8.4, why is a small amount of sulfuric acid added? Remember, sulfuric acid's a strong acid, so it dissociates completely, releasing H plus ions and SO4 2 minus ions, which means that you have a lot more ions in solution. And what that does is that it increases the conductivity within the solution, and that's why that acid is added. 8.5, after running the cell for 20 minutes at 2 amps, approximately 1.5 times 10 to the 22 electrons have left the negative terminal. Write down the half reaction that takes place at the pure copper electrode. Just a reminder that the pure copper electrode is negative, and therefore the copper 2 plus ions in solution are attracted to the negative electrode, and so the half reaction is copper 2 plus gains 2 electrons to form copper. Alright, 8.5.2, use a calculation to show that approximately 0.025 moles of electrons pass on to the copper electrode. What we're doing here is we're recognizing that 1.5 times 10 to the 22 electrons, if we divide that by Avogadro's number, it will simply tell us how many moles of electrons. So it's 1.5 times 10 to the 22 divided by 6.02 times 10 to the 23. It's the number of particles in a mole, and that gives us our 0.025 moles. And then finally, hence calculate the mass of pure copper that should be deposited during the experiment. Firstly, let's go back to the half reaction. Copper 2 plus is gaining 2 electrons to form copper. Now we're interested in the link between the number of electrons and the amount of copper that's formed. So notice that the ratio is 2 moles of electrons forms 1 mole of copper atoms. So the first step is to recognize that we need to divide the number of moles of electrons by 2 to give us how many moles of copper is formed, so 0.0125. Then we'll use the formula mass is number of moles times molar mass. Number of moles is 0.125, and the molar mass of copper is 63.5 grams per mole, and that gives us 0.79 grams of copper that was formed.